Yeah. Okay, so this morning we will be finishing off the section of chapter 5, uh, 5.6. We won't be doing 5.7, and then we're going to begin chapter 6, section 6.1. Um, I I think, let me double check here. I don't, the last class, I don't remember getting homework from persons from the last class. So if you did the homework and you just didn't send it, please send it so I could give you credit for the homework that we did in the last class. So last class we were looking at um, irrational numbers and real numbers, and you would have gotten some homework for that. So if you did it, please send it to me so I could give you the credit for doing the homework. The midterm, I sent your scripts to you, and I did extend opportunity for you to redo it, the same paper, and send it. I didn't see any response, so I take it you are satisfied with what you got. I heard from Miss Pratt, so I guess I will see something from her soon. But um, if you're satisfied with the grade, then there's no need to do it. But I really like the idea of you getting as much practice as you can and looking over a question to see what you did wrong, so you could figure out for future reference uh, how to approach a question, and it helps to reinforce the concept once you realize what you did wrong and you do it over to correct it. Okay, so that is why I extended that opportunity to you, and you could always average the new score with what you got on the test. Um, of course, you'll have to do the entire paper, not just the ones you got wrong, but the entire paper over and send it. But I've been having some problems when I try to print stuff that you take a picture of. A lot of times it's very dark, and when I mark it, it's hard to even see the markings. And when I send it back to you, it gets degraded further. So that's why I'm asking if you could scan, or if you could somehow get a very clear copy. But I find that phone photographs tend not to be very clear unless you have an app on your phone that can actually scan. There's a couple of apps that you can download that can actually scan. Um, I think one of them is called, let me see. If you have Office 365, On your phone, there is something called Lens, Lens. Let me double check here. Yeah, Lens, Lens. That's a free app that I think it allows you to scan also. And so you could get a fairly clear image of, let's see. Yeah, of items that you take a picture of. Okay. All right, so for today then, we're going to go to page 282 of your text. And we are looking, the first section is looking at exponents and scientific notation, and then the second section will be doing some algebra. Okay, so with this section, we have on page 282, a table with the properties of exponents. So we have the product rule, the power rule, the quotient rule. And of course, you should know that the product rule, which is the first one on the table. Are we all hearing me?
Yes. Yes.
Okay. All right. Yeah, so the first one, the product rule, basically says that when you are multiplying numbers expressed in exponent form, and by the way, when we talk about exponent, we are talking about numbers expressed as a power. So another term for numbers expressed as a power is numbers expressed in exponential form. So if you have to multiply two numbers expressed as a exponent, once they have the same base, so the base in this case would be b for both of these. If you have b to the m power multiplied by b to the n power, you add the powers and keep the base. And so the explanation is right here. And to give an example, 9 to the 6 times 9 to the 12 would be 9 to the 6 plus 12, which is 9 to the 18. Now, if the base is not the same, so if I give you, for example, 6 to the 3rd times 5 to the 4th, you can't use the exponent rules for that, the product rule. That does not apply here. It only applies where the base is the same. So both of these have the same base, which in this case is 9. The base here is 6. The base here is 5. So you cannot use the power or the product rule in this case to simplify this expression. With the power rule, if you have a number in exponent form to raise to a power, then you multiply the powers or multiply the exponents. So we have two examples here. 3 to the 4th raised to the 5th power is 3 to the 4th times 5, which is 3 to the 20th. Then we have another example, 5 to the 3rd in brackets raised to the 8th power is equal to 5 to the 3 times 8, which is 5 to the 24th power. And then the quotient rule, of course, quotient have to do with division. So when we have two numbers expressed in exponent form, once the base is the same, then you can subtract the powers to simplify the expression. So in this case, you have 5 to the 12 divided by 5 to the 4th. Simplified with 5 to the 12 minus 4 equals 5 to the 8th. And second example follows the same principle. Now, following from the table that we just looked at, we can come to some conclusions. And this first conclusion has to do with what is called the zero exponent rule. So what they're saying that if you have, in this case, we had, as an example, 12 minus 4. In this case, we have 40 minus 5. But what about if you have a case where the powers are the same? So in this case, you have 4 to the 3rd divided by 4 to the 3rd, which gives you 4 to the 3 minus 3, which is equal to 4 to the power 0. So they use that to show you that if you were to expand this and say 4 to the 3rd is 4 times 4 times 4, 4 to the 3rd is 4 times 4 times 4, which gives you 64 in both cases. 64 divided by 64 is equal to 1. So if you get 1 for this answer, and you get 4 to the 0 power when you simplify it, basically what this is suggesting is that 4 to the 0 power is the same as 1. Okay, because essentially this is the same as that. But in the first case, we were just simplifying it. In this case, we were actually evaluating it to work out the value of 4 to the 3rd. And once you work out the value of 4 to the 3rd, you get 64. 64 divided by 64 is 1. So what they are suggesting here, that 4 to the power of 0 must be equal to 1. And this is an example of what is referred to as the zero exponent rule. And the zero exponent rules basically says that for any real number other than 0, a real number to the power of 0 is equal to 1. So it doesn't matter what the number is. So any number raised to the power of 0 is equal to 1. Okay, so this is just one example, but any number raised to the power of 0 is equal to 1. All right, so we have some examples here. So in this first example, you are given 7 to the power raised to the 0 power. Of course, the answer is 1 right here. Pi, of course, we looked at pi when we were dealing with irrational numbers. Pi raised to the power of 0 is 1. In this case, we have negative 5 raised to the 0 power. And you notice the negative 5 is in brackets. So you're raising the negative 5 to the power of 0. Answer is 1. And then in this last one, negative of 5 to the power of 0. You notice in this case, the answer is negative 1. And the reason for that is because the 5 is that what we are raising to the power of 1, not negative 5. When we want to raise negative 5 to the power of 0, we put the negative 5 in brackets. But without the brackets, the power is only applying to the 5, the 0 power. So the answer would take the sign that was there before. So you want a negative of 5 to the 0 power. So 5 to the 0 power is 1, so the negative of that would be negative 1. Okay? So that's why we have a negative here in our answer. So that's different from this one, which actually is asking you to raise negative 5 to the 0 power. Whereas this one is just asking you to raise 5 to the power of 0, but give the negative of that answer. Okay, So you have 4 similar questions here. I'll give you a minute to answer them. Okay, so Miss Pratt, what you have for number 1? For A.
For A, I have 1.
Okay. Miss Nairn, B.
B, I have 1.
Okay. Miss Fernanda. What you have for C?
For B, is it 3?
C, what you have for C? Miss Fernanda?
I have 1.
Okay, what about D?
-1.
Okay, thank you. Okay, so A, B, and C
Yeah.
would be all 1, and then for D is -1, because you have 14 to the 0 power, and you want the negative of that for D. All right. So the next slide, we have properties of exponents, the negative exponent rule. So we're just looking at the 0 exponent rule. Now we have the negative exponent rule. And with the negative exponent rule, you're going to look at this example here where you have 4 to the 3rd divided by 4 to the 5th. And based on the quotient rule, to simplify this, we subtract the powers. So if you subtract 5 from 3, you're going to end up with a -2. So 4 to the 3rd divided by 4 to the 5th is equal to 4 to the -2. But if we were to work this out, evaluate it, expand the terms, is, as you see shown here, 4 to the 3rd is 4 times 4 times 4. 4 to the 5th is 4 times 4 times 4 times 4 times 4. And if we cancel out, you're going to end up with 1 over 4 to the 2nd power. So the same question is being done. One method, we are simplifying it using the rule of subtracting the powers because we are dividing. And here in this other working out, what we are actually doing is expanding and simplifying, and we get 1 to the 1 over 4 squared. So 4 to the -2 can be written as 1 over 4 squared. And so that brings us to what is referred to as our negative exponent rule, which is stated at the bottom here. If B is any real number other than 0, and m is a natural number, then b to the minus m power is equal to 1 over b to the m. And you notice once you put the in fraction form, you eliminate the minus sign in the power. So another way of writing b to the negative m is to write it as 1 over b to the m. Note there's no negative sign here once we change it into that fraction form. Okay, so that is what is called the negative exponent rule. And so in the same way, we can change the negative power to the fraction form. If you got the number in fraction form, 1 over b to the m, you should also realize that it could be written as b to the negative m. So we could do the reverse. Okay, that's your negative exponent rule. So we have some examples here. It says use the negative exponent rule to simplify. So the first one is 8 power negative 2. So we could write it over as 1 over 8 to the second power. 8 to the second power is 8 times 8, which is equal to 1 over 64. Following the same pattern, 5 to the negative power negative 3 is 1 over 5 to the third power, which is equal to 1 over 5 times 5 times 5, which is 1 over 125. And then in this last one, C, 7 to the power negative 1 is the same as 1 over 7 to the power of 1. And 7 to the power of 1 is equal to 7. And so the answer in simplest form is 1 over 7. So that's your negative exponent rule. So I'm going to try a few now. So I ask you to look at those three, simplify them using the negative exponent rule. Okay, so Miss Pratt, what you have for number one? For A, sorry.
For A, I have 1 over 9 to the second power.
Mm-hmm.
That would be equals 1 over 9 times 9 equals 1 over 81.
Okay, thank you. All right. Miss Nairn, what you have for B?
I have 1/6 to the third power equals 1 over 6 times 6 times 6
Mhm.
equals 1/216.
All right, thank you. And Miss Fernando, C?
I have 1 over 12 to the first power,
What
and then I
power?
have 1 over 12.
Okay, 1 over 12. Okay. So that should be 1
1 over
over
12, yeah.
12 to the first power, which is equal to 1 over 12. Okay, thank you. All right, so that is your negative exponent rule. All right, so on page 284 of your book, they have a review of powers of 10. And it's useful to know that we can abbreviate or use a shortcut, then you want to call it that, for how to determine how many zeros to put after the 1 when we have certain power of 10. So it says a positive exponent tells how many zeros follow the 1. A negative exponent tells how many places there are to the right of the decimal point. So in the first one, they give you 10 to the 9th as an example. Okay. And 10 to the 9th is 1 followed by 9 zeros. So that's, in this case, 1 billion. Now, when it comes to the negative exponent, it's telling you how many places there are to the right of the decimal point. So if you have 10 to the negative 9, it means that there are 9 places to the right of the decimal point. So 10 to the negative 9. So you're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So to the right of the decimal point, you have 9 places. Trying to see if I could. Okay. So to the right, you go 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 places to the right of the decimal point. That's what the negative exponent is telling you, how many places there are to the right of the decimal point. Whereas with the positive exponent is telling you how many zeros follow the 1. Okay. So that is useful for when we have to work with numbers that we express in scientific notation. So it says a positive number is written in scientific notation when it's expressed in the form a times 10 to the n. So that's 10 to some power, where a is a number greater than or equal to 1 and less than 10. So a must fall between 1 and 10. And n is an integer, which means n could be positive or negative. Now it says if n is positive, move the decimal point in a to the right n places. If n is negative, move the decimal point in a to the left, the absolute value of n places. And of course, you should remember this symbol here, absolute value. Absolute value refers to the number of places you have to move. So absolute value is always positive. So even though the power may be negative, we are moving based on the absolute value of that negative exponent. And so this will make more sense when we look at an example. So in this example 3, you're given two numbers to write in decimal notation. So these numbers are in scientific notation. So the first number is 2.6 times 10 to the 7. Okay, so this number is now in scientific notation. The first number is 2.6, which is greater than or equal to 1 but less than 10. And the second is 10 raised to some power. So based on what they're saying, if n is positive, move the decimal point in A to the right n places. So in this first one, n is equal to 7. So you're going to move this decimal.
I come in now.
You're going to move the decimal point 7 places to the right. So you'll see the solution there. 2.6 times 10 to the 7th. The power is 7. So you're going to move the point 7 places to the right. And so, oops, sorry, just a sec. Hello. For some teachers, maybe I'm not aware of it. I'm not aware of it. Okay. Sorry about that. Okay, so you, in this case then, the point was between the 2 and the 6. So if you move it 7 places, it's going to go 1, 2, 3, 4, 5, 6, 7. So you end up with 26 million. Now, when the exponent is negative, what they're saying is that you're going to move to the left the absolute value of n. So you look at this one, 1.1 times 10 to the negative 4 power. So the point was between the two ones. So if you move to the left 4 places, going to go 1, 2, 3, 4. So of course you're going to use zeros to fill in the spaces. And so you end up with 0.00011. Okay. And so that's the decimal form of those numbers. So both of these are in scientific notation. And what we just did was to write them as numbers in decimal notation in regular format. So I want you to attempt these two, write them in regular form or what they call decimal notation. They are now in standard form. Give me a minute to do those two. Okay, Ms. La Rochelle, can you do the first one? Ms. La Rochelle, are you there? Yeah, she is not. Okay, Ms. Pratt, and what you did for the first one.
So the first one, I would have 8 zeros, and then the 74 and then 8 zeros behind it.
Okay, 7, 4, 1, 2, 3, 4, 5, 6, 7, 8. Put a comma there, comma there. So the point was here. You go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So it's 7,400,000,000. Okay. Thank you. Miss Miss Fernanda, what you have for the next one? Oops. Fernanda, are you there? Miss Nairn, are you there?
I'm here.
Okay, tell me what you got for the next one.
Okay, I have 0 point and 5 zeros, 3017.
Okay, thank you. So the point was right here, and we're gonna move 1, 2, 3, 4, 5, 6. Okay, yeah, that's correct. All right. So it's 0.00003017. Move the point 6 places to the left. Okay, so what we just did then was converting from numbers in standard notation or scientific notation. Some people say standard form, scientific notation into decimal notation. So now we're going to do the reverse, which is page 286 of your book, which is to convert decimal notation to scientific notation. Okay, so it says to write a number in the form a times 10 to the n power, determine a, which is the numerical factor, which must fall somewhere between 1 and 10, and move the decimal point in a given number to obtain a number greater than or equal to 1 and less than 10. Determine n, the exponent, okay? The absolute value of n is the number of places the decimal point was moved. The exponent n is positive if the number is greater than 10 and negative if the number is between 0 and 1. So we have two examples. In this first example, we have 4,600,000. We want to change that to scientific notation. So the first part of your number has to fall somewhere between 1 and 10. And so you're going to have to move the point. The point is right now at the end, right here. So we're going to move the point to get the first part of the scientific notation to fall between 1 and 10, which would cause it to be 4.6. And so in order for us to get a 4.6, then we'd have to move the point 1, 2, 3, 4, 5, 6. So it's going to be 4.6 times 10 to the 6th power. Now, because the number that we started off with was greater than 1, our power is going to be positive. Any number, like in the second example where the number is less than 1, 0.000023 is less than 1, the power is going to be negative. The exponent is going to be negative. So we're going to follow the same principle. We need to get the points here, the 2.3, because the first part of the scientific notation must fall between 1 and 10. So the point is going to be between the 2 and the 3. And we now have to see how many places we need to move that point. So you got to have it move it 1, 2, 3, 4, 5. So we have to move it 5 places. So it's going to be 2.3 times 10. But because the number that we started off was less than 1, then the power is going to be negative. So that's why we have 10 to the negative power of 5 here. Okay, so that's your converting from a regular decimal number into scientific notation. So you first number falls between 1 and 10. Second is a power of 10. If the number is greater than 10, then your power is positive. If the number is greater than 1, the power is positive. If the number is less than 1, then you're going to have a negative power. Okay. All right. So when you try those two, write those two in scientific notation. Miss La Rochelle, are you back with us?
I'm here.
Okay, I called you earlier. I didn't get an answer, so I want you to do the first one. Miss La Rochelle?
Yes.
Yeah, I want you to do the first one. 4A.
Would that be 74.1 times 10 to the 7 power?
The first number has to fall between 1 and 10. It can't be greater than 10. So it wouldn't be 74. So that'd be 7.41. 7.41 times 10 to the
7 power.
7th. Okay, so the point is, you placing the point here, and it was here. How many places you have to move it?
9.
Okay. So it's 10 to the 9th power. Okay, thank you. That's 7.41 times 10 to the 9th power. Okay, Miss Nan. You with
Okay,
us?
so it's
Mhm.
9.2 multiplied by 10 to the negative 8th power.
Okay, let's see. 2, 3, 4, 5, 6, 7, 8. Okay. 9.2 times 10 to the negative 8. Okay, so we are now able to change from regular decimal notation into scientific notation. So the next thing we'll do now is to do calculations using scientific notation. Sometimes when we have very large numbers or very small numbers, it may be easier to do the calculations if you have the numbers in scientific notation, and you could perform your operations in that format. So it says here, we use the product rule for exponents and multiply numbers in scientific notation. Okay, so we have the example here where we are given 3.4 times 10 to the 9th multiplied by 2 times 10 to the negative 5 raised to negative 5. It says write the product in decimal notation. So if you study what is shown here, because we are multiplying, we can always reorder the multiplication. So we could multiply the, in this case, A and B, and then multiply the powers of 10. So what they have done to solve this is they have reordered the multiplication. If you remember when we were doing the properties of real numbers, one of those things about multiplication is that you, the order in which you multiply, once you are strictly multiplying, the order in which you multiply does not affect the result. So what they have done is to rewrite this 3.4 times 2, and then 10 to the 9 times 10 to the minus 5, raised to the power minus 5. So 2 times 3.4 gives you 6.8. And then 10 to the 9 times 10 to the minus 5. Because you're multiplying, you're going to add the indices, which is the product rule. The base is the same. So it will be 10 to the 9 plus minus 5, which ends up being 10 to the 4th power. So 6.8 times 10 to the 4th, you're going to move the point 4 places to the right. So you end up with 68,000 as your answer, because they want the answer in decimal notation. If they ask you to leave your answer in standard form, then you would stop right here where it says 6.8 times 10 to the 4th power. But because they want it in decimal notation, then you would expand it to 68,000. All right, so I want you to follow that same pattern and do this one. 1.3 times 10 to the 7th multiplied by 4 times 10 to the power of negative 2. Okay, Ms. Pratt, so tell me what you did so far.
1 second, I still working it out.
Okay.
1 second. Okay, so 1.3 times 4, close bracket, 10 to the 7 power times 10 to the negative 2. Then I did the 5.2 times 10 to the 7 power plus negative 2. Then 5.2 times 10 would give us 15.2.
Okay, hold on. 7 plus negative 2 gives you what?
5.
Okay, so it's 10 to the 5th power. Okay.
So 5.2. Sorry, that'll be 15.2. Am I correct? Because that'll be
Okay.
5.2 times 10, which
No,
will be
it's
the
10.
15.
No, it's 10 to the 5th power.
Right, I have that.
So you're going to move the point how many places?
5 places.
Right. And you're going to move it to the right or the left.
You're gonna move it to the right.
Okay. So the point was right here between the 5 and the 2. So you're going to go 1, 2, 3, 4, 5. So you have your 2, and you have to put zeros in the place, and the point would be at the end. So your answer is 520,000.
1,000.
Okay.
Mr. Allen,
Yes, ma'am.
I have a quick question.
Mm-hmm.
Walk me through the first part, how you get, y'all got the 5.2, please.
Okay. So what we did, oh, okay. So the first thing was 1.3 times 4 times 10 to the 7 times 10 minus 2. So what we did, we reordered the multiplication. All of this here is multiplication straight through, and with multiplication and addition, it doesn't matter what order you do it in. So because we want to deal with the whole number portions, we just put the 1.3 and the 4 together, and then we put the powers together, 10.7 and 10 to the 7 power and 10 to the negative 2. So 1.3 times 4, which is what we have. The result is this, 5.2. And then 10 to the 7 times 10 to the minus 2 gives you 10 to the 5th power.
Okay,
Yeah. Okay.
thank you.
So we reorder it, and then we simplify from there. Okay. So I guess I don't have to say this again, but I guess I'll still say it as we go through these. I hope persons are taking notes, because we're only doing one practice question, but you're going to get several for homework. So if you have the exams written down, then it's helpful when it's time for you to do the homework, so you could see how to set your work up. Okay. So now we were looking at multiplication. And so the focus here for this, what we were just doing, was using the product rules for exponents to multiply numbers. So that's what we are dealing with just now. So you will see if you have a number in standard form or scientific notation, you could change the order and deal with the whole number portion and then deal with the power section. And then you could simplify your answer in decimal notation. Well, depends on what the question asked you for. So in this case, they wanted your answer in decimal notation, but if they wanted in scientific notation, then you would stop right here where it says 5.2 times 10 to the fifth, but they asked for the answer in decimal form. So we also have cases where we could simplify by dividing. So we just did multiplication, but sometimes we can also divide numbers in scientific notation. So we have what is called a quotient rule. And so that's the rule we're going to be using here. With the quotient rule, we subtract powers. So if you have a to the times 10 to the n divided by b times 10 to the m, you could divide a by b and multiply it by 10 to the n minus m. Okay, so it says subtract the exponents on 10 and divide the other parts of the numbers separately. And so we have one example here. So you're given 8.4 times 10 to the negative 7 power divided by 4 times 10 to the negative 4 power. They want you to write the quotient in decimal notation. So we have here 8.4, okay? So we rewrote the same question that's up here, but what they did is to separate this portion of it from the exponent portion. So 8.4 divided by 4 gives you 2.1. And then the exponent portion, 10 to the minus 7 divided by 10 to the minus 4. You subtract the powers, so that'll give you 10 to the minus 7 minus 4, or minus negative 4. And so negative 7 minus negative 4 is the same as negative 7 plus 4, which gives you negative 3. So 2.1 times 10 to the negative 3 would be the scientific notation of your answer. So if the question asks to leave your answer in scientific notation, you would stop right here. 2.1 times 10 to the power of negative 3. But because they want it in decimal notation, as you see up here, then you're going to convert this now by moving the point 3 places. But because it's a negative power, our number is going to be less than 1. So you're going to move the point to the left 3 places. So the point was right here between the 2 and the 1. So if you go to the left, 1, 2, 3, then that's how we get the 0.0021 as our result. Okay, so that's your example of dividing numbers that are in scientific notation form. So I want you to try one now, where you have to apply that same principle, where you have to divide numbers that are written in scientific notation and give your answer in decimal notation. Give you a couple minutes to, well, not a couple minutes, a minute or so to do that. Okay, Ms. Nan, you tell us what you have so far.
Okay, so I did 6.9 over 3 multiplied by 10, negative 8 over 10, negative 2. And then I got 2.3 multiplied by 10, negative 8, minus negative 2. And then I got 2.3 multiplied by 10 to the negative 6 power.
Mm-hmm.
And then decimal would be 0.5023.
Okay, thank you.
Hi, Mr. Allen.
Yes, ma'am.
Hey, I don't follow where she got the 2.3.
Okay. Okay, so 3 into 6.9 is 2.3. Okay, because remember now we're separating this portion, 6.9 over 3, and then the 10 to the power negative 8 over 10 to the power negative 2. So when you divide the 6.9 by 3, you get 2.3 here. And then when you do this portion, you're going to have to subtract the powers. So we get the negative 6. And then because this is a negative power, you're going to move the point to the left 6 places. So 1, 2, 3, 4, 5, 6.
Okay,
Okay.
I see what I was doing wrong. Instead of the 6.9, I was doing the 6 times 9 divided into 3.
Oh, yeah, that's a decimal, 6.9. Yeah.
Thank you.
Okay then. So that was Miss Nguyen. Okay. Okay. Okay, so in these last two examples we looked at, the numbers were already expressed in scientific notation. So sometimes we may be given large numbers and we can convert the large numbers into scientific notation and then do the calculations. So in this section here, which is on page 288 of your book, they're talking about multiplication and division involving very large or very small numbers that can be done by first converting the numbers to scientific notation. All right, so once you convert the numbers to scientific notation, you follow the same rules we looked at just now for multiplication and division. So in this example, you are asked to multiply 0.000064 times 9,400,000,000. First, they ask you to express them in scientific notation and decimal notation. So here, you are given the number, you write the question out, and then 0.00064 in scientific notation is 6.4 times 10 to the power of negative 4, and 9,400,000,000 is 9.4 times 10 to the 9th power. So once you have the two numbers expressed in scientific notation, then you could reorder the numbers so that the powers are together, okay, and the numbers values between 1 and 10 are together. So 6.4 times 9.4 and 10 to the negative 4 times 10 to the 9th. So when you multiply 6.4 times 9.4, you get 60.16, and then 10 to negative 4 plus 9, and we're adding because we're multiplying. And so that gives us 60.16 times 10 to the 5th. Negative 4 plus 9 is 5. And so this now is not exactly in scientific notation because this 60.16 doesn't fall between 1 and 10. For it to be in strict scientific notation, the first number must be between 1 and 10. This number is greater than 10. So what we'll have to do to get it in strict scientific notation is to change this 60.16 so that it falls between 1 and 10, which means we're going to have to move the point one more place to the left, which gives you 6.016 and times 10, and that would be 10 to the first power. Okay, so they didn't put the 1 there, but that's the same as 10 to the first power. And then once you remove the brackets, you're going to multiply this 10 to the first times 10 to the 5th, which gives you 10 to the 6th power. So in strict scientific notation, your answer would be 6.016 times 10 to the 6th. And then the part B wants to answer in decimal notation. So if you want your answer in decimal notation, you're going to move the point 6 spaces to the right. So that's going to be 1, 2, 3. And then you're going to have to add 3 zeros to get the next 3 places. And so that's how they got the answer here. 6,016,000 is your answer in decimal notation. So you have the answer as standard form, scientific notation, and you also have the answer in decimal notation. All right. So the key thing that we didn't see before was right here, where you got an answer that looks like it's in standard in scientific notation, but it's not quite so because this 60 is greater than 10. The number, this number, the first number for your scientific notation must always fall between 1 and 10. So you must always check when you multiply or divide to make sure this number here is between 1 and 10. If it is not, then you're going to have to adjust it so that it falls between 1 and 10, and then say what power of 10 you have to multiply it by to get back the original number. So in this case, you'd have to multiply this 6.016 by 10 to get it back to 60.16. So this is power 10 to the power of 1. You multiply the 10 to the power of 1 times 10 to the power of 5, you get 10 to the power of 6. Okay, that's it for that. So I want you to try this one, which is similar. So first you're going to convert the two numbers to scientific notation, do your multiplication, and then give your answer in scientific notation and also in decimal notation. Okay, Ms. Fernanda, can you tell me what you did so far?
Oh, I'm still working. So far I have 3.6 times 10 to the negative 3
Mm-hmm.
times 5.2 and 10 to positive 6.
Mm-hmm.
To the power, raised to the power of 10. What am I saying? Yeah, raised to the power 5.2 times 10 raised to the power 6.
Mm-hmm.
That's where I stop. I'm still working.
Okay then, continue then.
Okay, so I have 18.72. Then it's gonna be 10 to the negative 3, raised to the power of negative 3. Well, plus positive 6, plus 6.
Mm-hmm.
And I left it in that form now. I'm trying to be
Okay, so negative 3 plus 6 gives you what?
positive 3.
Okay.
So I have to put,
Okay, is that strictly in scientific notation form?
yes.
This first number, 18.72, does it fall between 1 and 10?
Pardon?
The 18.72, is it greater than 10?
Mm-hmm.
So if it's greater than 10,
Yes.
then we have to fix it. Because this
Okay.
first number has to be between 1 and 10.
Oh, so I'll have to. So
So
I move the decimal place to the right. I mean to the left.
right, so it could be 1.872 times 10 times 10 to the third. So that becomes 1.872 times 10 to the fourth power. Now it will be in strict scientific notation because the first part of it is between 1 and 10 multiplied by a power of 10. Okay, and then now we need to change that to decimal notation. So this is the first part of the answer. Now the second part is to change it to regular decimal notation. So we're going to move the point. How many places?
4 places to the right.
Okay, so 1, 2, 3. So it's going to become 1, 8, 7, 2.
1872.
18,720. Okay, 1, 2, 3, 4. So we just need to add a 0 there. Okay, so that's part B. Okay.
Okay.
All right, so that's it for that one.
So we don't have to put the power or anything. We just work it out for B. That's it.
For B, they just want it in decimal notation, so you don't need the
Okay.
power. Only for A, where they want you to put it in scientific notation. So scientific notation would be 1.872 times 10 to the fourth. for B, where they want it in decimal notation, you just expand it, it will be 18,720. And
Okay.
that's it. Yeah. Any questions from anybody else on that? Are we all clear? Miss La Rochelle, you following?
I'm clear.
Okay, and Miss, who didn't I hear from now? That was Miss Fernanda just now. Okay, Miss Nairn and Miss Pratt.
Yes, I
Yes.
got it.
I'm good with it.
Okay, all right, thank you. All right, so moving on then. Okay, I think I'm gonna skip this for now, but basically what this portion is saying is that sometimes we have these numbers are not in isolation. We have real life situations where we have to deal with large numbers. And in some cases, the numbers are written in scientific notation. So it can be helpful to know how to read and do calculations with numbers in scientific notation. So this is an example of a type of question. Of course, this applies to the US where they talk about the national debt and they wanted to figure out, based on what the national debt is and the population of the country, which they have as 200 million, how much each citizen would have to pay if every citizen was responsible for paying off the national debt. And so what they basically did was divide the national debt by the population. And so the working is shown here. And so you could look at that when I send the sheet to you. And I'm going to skip this checkpoint because I want us to move on to the next section, which is algebra. Okay. Okay. So the chapter 6 focuses on algebra. And because our course is kind of limited time, we just have to kind of make these abrupt changes from time to time. Sorry about that, but we want to try and cover at least 6.1, which is the first section of chapter 6, which begins on page 308. So this portion here is just looking at some of the terms involved in algebra. So we are looking at algebraic expression. Of course, I guess most of you will remember that when we talk algebra, we are actually using letters or variables to represent unknown numbers. Okay, and that's the feature of algebra. An algebraic expression is a combination of variables and numbers, and using operations such as addition, subtraction, multiplication, and division, as well as exponents, powers, or roots. We have some examples of an algebraic expression shown. All right, there are 3 examples shown here. You have x plus 6 as this one says x squared minus 6. Okay, 6x by itself. Okay, and then this one says square root of x plus 7. All of those are examples of algebraic expression. The expression could have simply one term or multiple terms. Okay, most of these have 2 terms, and one of them is just 1 term. So it could be letters, it could be numbers, could be numbers and letters, and it could be radicals. Okay, now we did order of operations earlier, but the order of operations also applies when we're doing algebra. All right, so they say you must perform operations within the parentheses first. And in the case of algebraic expressions, sometimes you have multiple sets of brackets. So what they're saying is that you must do the innermost brackets first and work outwards. So sometimes you'll have brackets within brackets. So you did the innermost brackets and then you work yourself outwards. Okay. If the algebraic expression involves a fraction, treat the numerator and denominator as if they were enclosed in brackets. And then you do exponents after brackets, then multiplication and division in the order they occur from left to right. And then lastly, we do additions and subtractions as they occur, working from left to right. Okay, so the basic principle is the same as when we're dealing with whole numbers. So we have an example here where you are asked to evaluate. Now, when you're asked to evaluate, basically you're given a value and you're going to substitute the value into the expression. So in this case, you're told that you have 7 plus 5, open brackets, x minus 4, raised to the third power, and you're told that x is equal to 6. So you know the value of the variable is 6, so you're going to put that in place of the x, and then you simplify the expression. So the first thing you will see here is that we have taken out the x and put 6 in its place. So the x was here. You're told that x is 6, so you write over the expression and remove the x and put the 6 in its place. So that's your first step. Now, the next step, they said, is to deal with the brackets. So the brackets had 6 minus 4. 6 minus 4 is 2. So you put the 2 right here in place of the 6 minus 4. So you're going to write it over as 7 plus 5 times 2 to the third power. Okay, so once you finish that, then the next step is exponents, if you have any exponents, and you do have exponent, because 2 raised to the third power gives you 8. 2 to the third power is 8. That's 2 times 2 times 2 gives you 8.
Mari said, oh, Grammy. Oh, no.
Hey, Dr. Allen.
Then
Hey, can I get
four-
this and talk for a few minutes, please?
You know who you
Can
are.
you hear me?
oh, okay. So 2 to the 8, 2 to the third power is 8. And then you do the multiplication, 5 times 8. Multiplication is done before addition. Multiplication division is done before addition and subtraction. 5 8s are 40. And then finally you do your addition. 40 plus 7 equals 47. And that's your final answer for that question. Okay, so that is an example of how to evaluate an algebraic expression. You followed up the rules for order of operations after you substitute the given value for the variable into the expression. All right, so you have one here where you are asked to evaluate. You're given that x is equal to 13. You're going to put 13 in place of x in the expression and then follow the rules for the order of operations to simplify. I'll give you a couple minutes to, a minute or two to work on that one. Okay, Ms. La Rochelle, tell me what you have so far.
I have 8 plus 6, open brackets, 13 minus 3 to the power of 2, close
Mhm,
power of 2. Then
mhm,
I have 8 plus 6, open bracket, 10 close bracket to the power of 2,
mhm,
8 plus 6, open bracket, 100 close bracket,
mhm,
8 plus 600
mhm.
equals 608.
Okay. All right, thank you. All right, so that's 608. Thank you. All right, so um, okay, we have another example. Let me see. All right, so the only difference with this example here now is that you have the variable appearing more than once. So in this other example, we only had the variable appearing once in the question, but here you have the variable appearing multiple times. So this time the variable is equal to -6. So you're going to substitute the -6 in place of the x. So x squared, that would be -6 squared, 5 times -6, and then -3. So where you see the red, they substituted the -6 that was given to you in those spaces. So -6 squared would be 36. 5 times -6, well, we're going to deal with that after, -6. So all they did was the exponents. Then after the exponents, then they did the multiplication. 5 times -6 gives you -30. Then you're going to do the addition and subtraction in the order that they appear. Since this came first, you're going to do that first. 36 plus -30 gives you 6. And then 6 minus 3 is equal to 3. Okay, so you simply just substitute the values given into the expression and simplify it using the order of operations. So I'm going to ask you to look at this one where you have two instances where the variable appears and the value for x is -5. So we're going to substitute that -5 into the expression and evaluate it. Anytime you're asked to evaluate an algebraic expression, basically you're given the value of one of the variable, and you have to substitute into the expression to work out the value of the expression based on the given value for the variable. Give you a minute or two for that. Okay, Ms. Pratt, I'm going to start with you. Ms. Pratt. Oh, Ms. Pratt is there. Yeah. Okay, Ms. Pratt, tell me what you have so far, please. Pratt, are you there? Okay, Miss Nairn, are you there?
I'm here.
Okay, tell me what you have.
So I have -5, I guess in brackets, squared, plus 4, open bracket, -5, close bracket, -7. And then I have 25 plus 4, open bracket, -5, close bracket, -7. And then I have 25 plus open bracket, -20, close bracket, -7. And then I have 5 -7 equals -2.
Okay, thank you. All right, so -2 is the answer for that one. Okay, now this next example, we have more than one variable, but the principle is the same. Okay, so you're asked to evaluate -2x² plus 5xy minus y to the third. So you have two variables. You have x, which is 4, and y, which is -2. So you're going to follow the same principle with substituting the values that is given to you. So they have the x in red and the y in blue. So x was equal to 4, y is equal to -2. So basically, you're going to substitute 2 times 4 squared plus 5 times 4 times -2 minus y to the third power, which y is -2. So that's -2 to the third power. Okay, so we have done all the substitutions. Now we're going to start off with the powers first, because we don't have any brackets. These brackets here are just for negative numbers. They're not grouping brackets. So the power is this one. So that's 4 times 4 is 4 is 16. So we're going to write everything else except the ones that's in power in exponent form, which we have to work out. So this one we go to 16, then you put the 5 times 4, open brackets, -2 minus 8. Now we work, this is power also, to the third power. We work that out to -2 times -2 times -2 gives you -8. Okay. Now we finished doing that portion. Now we're going to look for a multiplication and division. Okay, multiplication is right here. -2 times 16 gives you -32. And then 5 times 4 times 2. Okay, 5 times 4 times -2. That gives you 5 4 is 20. 20 times -2 gives you -40. And then you bring the -8. So we finished with all the multiplication. So we're going to do the addition and subtraction in the order they appear. So you have -32 plus -40. That's -72 minus -8. All right, -72 minus -8 is the same as -72 plus 8, which gives you -64. Okay, so we got two variables to substitute, and then we just follow the same pattern of brackets, exponents, multiply and divide, add and subtract. Okay, so we're going to try this
Hi,
one
Ms.
here.
Wagner.
Yes, ma'am?
Hi, I have an emergency. I have to step out. I'll have to listen to the recording later on as soon as I'm through.
This is Ms.
So can you
Pratt?
excuse me, please? Yes, sir.
Okay then. All right. Okay then.
Okay.
All right. All right. So you could go ahead and do this one. checkpoint 3. So we got two variables here, x is 5, y is -1. I'm going to substitute that into the expression and then evaluate. Okay, so Miss Fernanda.
Yes,
Okay.
okay,
Go to-
so I have,
Mhm.
okay, so I have -3, open bracket, open bracket, 5, close bracket,
Mhm.
plus 4, open bracket, 5, close bracket.
Okay, hold on. The 5
No, sorry, no, 5
5 to the
plus,
you don't have the power?
no, plus. Oh gosh, I do this whole thing wrong. I didn't even write the power, sorry. Oh,
Okay. And then so plus 4.
yeah, plus 4 times 5,
Times 5.
and open bracket, -1, close bracket, minus, open bracket, -1, close bracket, to the third power.
Okay.
Let me see. because I did this wrong the first time.
Okay, so let's do the
So
power
now I have,
quotient first. -3, 5 to the
Yeah,
second power gives you what?
so I need -3 and 5 to the second power will give me 25.
Okay, so that's 25. And then we just put the +4 times 5 -1 minus, and then -1 to the third power should give you
-1.
okay, so that's -1. Okay, -1. So we finish all the powers and we don't have any group in brackets. So we're just going to do the multiplications. So we're going to have -3 times 25 gives you
-3 times 25 gives you -75
plus 4 times
plus the
5
4,
times -1.
and then now we work out
4 times
the 4
5.
times 5 is 20.
20 times -1 is
That'll be -20.
-20. Okay. And then -1 would be the same. Okay, if we want to put the -1 is the same as
1.
+1. Okay. So now the next line now, you're going to say -75 plus -20 gives you
-75 plus. It gives you -95.
-95
Yeah.
plus 1.
And then the next line would be -95. So that's plus 1 will give you -94.
Mhm. Okay, very good. All right. That's it. All right. So we just have to watch out for those negatives values. And also in this case, we had multiple integers, multiple variables, which we had to substitute for. And once we substitute, we do the brackets. If there are any group in brackets, then the exponents, multiply and divide, then add and subtract. Okay. All right. So in algebra, we have what I call equations. So far, we weren't doing any equations. What we were doing was evaluating expressions. An equation is different from an expression. In the case of an equation, we have what is the equal sign between two equations, to show that those two equations are equal. So that's what an equation is. Now, the formula is a type of equation. Okay, formula is a type of equation. So formulas are equations, but in the case of formulas, they help us, they give us the relationship between certain values, and we can use those formulas to solve problems. For example, you may remember things like how to find the area of a rectangle, area of a triangle, circumference of a circle. All of those are examples of formulas. And the formula is a type of equation. It's telling you that two expressions are equal, but the formula, after identifying relationship between different variables, we can write formulas to help us to solve for one or more of variable. And then this third concept here is mathematical modeling. Okay, that's the process by which we actually build formulas. Okay, so we study situations, study real world situations, and based on what we observe, we derive formulas, but we go through a process of modeling first, and then from there we would make the general formula to apply to several scenarios. Okay, so we have one example here where they studied some, it says in 2003, 28.5 million US adults browse internet personals and 17.4 million posted online personal ads as represented in the bar graph. Okay, so so that's 2003. Okay, trying to, okay, amount in millions of dollars. Here are three mathematical models where D represents the amount of money in millions of dollars and X represents the years after 2002. Which model best describes the data for 2004? So 2004 is this purple one. And so we have three different models. D equals 236 times 1.5 to the X power. X represent the years after 2002. Okay. And model 2, 127X plus 239. And model 3, D equals negative 54X plus 234X plus 220. Okay. So this D is supposed to be the amount of money in millions. So they want to know which one best describes 2004. Now, 2004, how much money was raised in 2004?
473.
473 million. So they want to see which of these three models best describe what happens in 2004. So what they did is to work out using the three models. Okay, so 2004 is 2 years after. Remember, X is the amount of years after 2002. So they put 2 in place of X for each of them. Wherever you see X, you put 2 in place of it, and you do your calculations. So the first one gives you 531. The next one gives you 493. And the third one gives you 472. But remember now, we said that according to the graph, 473 was the amount of money spent on online dating. So if you look at the 3 there, the closest one would be model, which model? It says 473. So which of the 3 models gave you the closest to 473? Model 1, 2, or 3?
Model 3.
Model 3. Okay, model 3 gives 472. Okay, which would be the closest of the 3. All right, so theirs was 472, whereas the actual graph shows 473. So sometimes insurance companies and actuaries use these types of modeling process to work out certain real world situations, and they try out different models to see which one would best. Sometimes one model will fit certain situations but not others, so we try to find a model that works best for a wide range of situations relating to a particular type of scenario. So this is just one example, and we have a checkpoint here, but I am going to skip that for now, and we're going to move on to this section here, which is on page 311. So we mentioned already that in algebra, each item that is separated by a minus or plus is called a term. So in this example, we have 3 terms. Okay, those parts of the algebraic expression separated by addition, subtraction are called terms. And then the numbers in front of each term, if it is called a coefficient. So in this case, the coefficient for the first one here is 7. Coefficient for this one is, well, they treat the negative as a sign here, so it's -9. And then, well, there's no variable for this, so we don't really call this 3 a coefficient. That 3 is really called a constant. So it says constant, a term that consists of just a number is called a constant. So this 3 would be a constant. It doesn't have a variable, so it's a constant. The x and the y are variables, and they have coefficient. In this case, it was 7. In this case, it was -9. Now it says like terms, terms that have the exact same variable are called like terms. So 7x and 3x, the variable is the same, so they are like terms. So you can add and subtract together in algebra, but if they are not like, you cannot add or subtract them. Okay. All right, so we did talk about commutative property when we're doing real number. So we have addition. It doesn't matter which order you add. Multiplication, the same thing. It doesn't matter which order you multiply. You get the same result. Then we have what is called associative property of addition. So if you have 3 numbers to add, it doesn't matter which 2 you add first, the result will be the same. And we also use the same principle for multiplication. If you have 3 numbers to multiply, it doesn't matter which 2 you multiply first. Okay, so that's your associative. So one has to do with the order. The other one has to do with the grouping. Doesn't matter which group you do first. And then we have the distributive property, where if you have a term outside the brackets, when you remove the brackets, you have to multiply each of the terms in the brackets by the term outside. So you see 5 times 3x plus 7. When you remove the brackets, it becomes 5 times 3x plus 5 times 7. So everything in the bracket is going to be multiplied by the term outside the bracket. And so that's your distributive property. Okay, so we want to simplify this expression here. So we're not doing any evaluating now because they didn't tell you what x is. So all you're doing is trying to simplify it by bringing together like terms if there are any. So first we're going to remove brackets. So we're going to multiply, in this case, by 5 using the distributive property. So 5 times 3x is and minus 5 times 7 minus 6x. Oops. So when you multiply 5 times 3x, you get 15x. 5 times 7 is 35. And then you bring the 6x down. So once you are done that, you can now bring the like terms together. The 15x and the 6x are like terms. So 15x minus 6x minus 35. And once you have the like terms together, you can simplify them. 15x minus 6x is 9x, and then minus 35. So you'll find you can't bring this any further because these are not like terms. So this is the simplest form of your answer. Okay, so I wanted to look at this checkpoint 5. Let's see if we could bring it to lowest terms, to simplest form. There's no value for x. You're not evaluating, you're simplifying. Okay, Miss Nan, tell me what you have so far.
Okay, so I have 7 multiplied
Mhm.
by 2x minus 7 multiplied by 3 minus 11x. And then I said 14x minus 11x minus 21.
Okay, let me put a 21. So 14x minus 11x minus 21.
And then I said 3x minus 21.
Okay, so that's it.
That's it.
Okay, thank you. Number 5. Okay. Okay, so that's that. All right, so now open it up a little bit here. So now we have something a little bit more involved. So we have 2 sets of brackets. So following the same principle, 6 times 2x plus 6 times 4. Now in this case, this is 2x squared. So 6 times 2x squared plus 6 times 2x squared plus 6 times 4x, and then 10 times 4x squared plus 10 times 3x. So 6 times that gives you 12x squared, 6 times that gives you 24x, 10 times 4x squared gives you 40x squared, 10 times 3x is 30x. All right, and then you bring the like terms together. 12x squared plus 40x squared plus 24x plus 30x. Now notice that they didn't put the x squared with the x. Okay, they are not like terms. So only x squared could be added with x squared and x with x. So when you add these two together, you get 52x squared, and then the other would be 54x. And that's the simplest form of your answer for this expression. Okay. Okay, so let's move on to this next example, following the same pattern that we looked at just now. Okay, that was Miss. So Miss La Rochelle, I want you to lead this one off.
You want me to work it first, or I'll tell you what to do?
You could tell us what to do.
Okay, 7 times 4x squared, which is,
No, just go through the whole thing first.
okay,
Then
7
7
times
times.
4x squared plus 7 times 3x plus 2 times 5x squared plus 2x.
Okay, so let's now do the multiplications.
28x squared
Mhm.
plus 21x
Mhm.
plus 10x squared plus 2x
Mhm. Then you're gonna bring the like terms together.
28x squared plus 10x squared plus
Mhm.
21x plus 2x,
Mhm.
38x squared plus 23x.
Okay. Thank you. Very good. Okay. All right, so this one wasn't too bad. We didn't have any negatives in it. Sometimes the negative can pose a little bit of a challenge. So we're gonna move on now to this next example. Now, in this example, the difference with this one now is that we have multiple brackets. Okay, so sometimes you have brackets within brackets. So you have here 8x plus 2, and then you have the square brackets, 5 minus x minus 3, which is in brackets, then you close the square bracket. So with questions like this, you do the innermost brackets first. So this one here would be the innermost, x minus 3. All right, now you're not given any value for x, so you can't evaluate. So you're just trying to simplify. And there's no number in front of this bracket. Okay, now in your book, what they're saying, drop the parentheses and change the sign of each term in the parentheses. Okay, so now I don't like that explanation. What is useful is that once you don't see any number, you could treat it like it's 1. So that's some books, that's what they do. So you just treat it like it's 1. So it's like you have -1 in front of the brackets. So if you multiply -1 times x, you're gonna get -x, and -1 times -3, you're gonna get +3. I mean, that's the same as just changing the signs in the bracket. That's a shortcut way of thinking of it. Okay. So once you do that, then you're going to get rid of the innermost bracket. So you're going to end up with 5 minus x plus 3. And then you still have that. You have some like terms in the bracket, so you could combine them. 5 plus 3 is 8. So that's going to give you 8 minus x. So once you simplify that, then you could do the distributive property. 2 times 8 is 16. 2 times x, in this case, that's minus x, will give you minus 2x. Okay, then when you finish, you're going to bring the like terms together. So it's 8x minus 2x plus 16. 8x minus 2x is 6x. 6x plus 16. And that's your simplest form of your answer for that expression. Okay, so if you have to remove brackets where you see a negative sign in front of the brackets, one quick way to deal with that is to change the signs of the numbers in front in the bracket. So this was positive x, it becomes negative x. This was positive x, it becomes negative x, and this was -3, it becomes +3. Or you could treat it as if you're multiplying by -1. -1 times x will give you negative x, -1 times -3 will give you +3. So that's another way to look at it. Okay, so now we have checkpoint 7. to do. Okay, so that was, let me see who I asked already. So I got Mr. Rochelle, Mr. Nanda. Okay. So I'm going back to Miss Fernanda for that one. I give you a minute or two to work it, and then I'll call on Miss Fernanda to answer. Okay, Miss Fernanda.
I get the difficult one. Okay, so 6x
Mm-hmm.
4,
Mm-hmm.
and I would work inside this bracket first. So I'm gonna 7 minus -2 would give me
Hold on.
9.
When you remove the brackets, what you get? The innermost bracket.
Oh, you mean, okay, so 7 minus x minus 2.
Well, you have the minus. You have to change the two signs.
So
See
that'll
when
be
you.
7 plus, yeah, the positive make the 2.
Mhm. So remember,
So
we have to treat this here like it's -1. -1 times x is -x, and -1 times -2 is +2. Okay.
mhm,
All right. So 6x plus 4,
plus 4,
and
and
the
then this
bracket.
will be 9 in the bracket. It'll be 9 minus x.
Okay. Mm-hmm. So 6x plus.
Now next line will be 6x plus 4 times 9 is 36
Mm-hmm.
minus 4x.
Mm-hmm.
Then now we collect the like terms. So we'll say 6x minus 4x
Mm-hmm.
plus 36. So now
Mm-hmm.
we'll have 2x plus 36.
Okay. 2x plus 36. Okay. Very good. So the main thing to remember now, when you have that minus in front of the bracket, you have to change the signs of both of the terms within the bracket, or multiply both by -1. And then you should be good to go from there. but you do the innermost bracket first, and then you work yourself outwards. All right, so that's basically it for today. So you have your, I already sent the presentation. So if you check your email, you should see it. And so you have the homework for 5.6, which is the exponents and scientific notation. The question numbers are here that you're to do. And then these are the questions. Okay, so these are the questions. And then for 6.1, which we just finished, which is the algebra, these are your questions to do. And that's page 314, but the questions are right here. Okay. And then these are your answers for the homework question. And if you have any issues, then you could let me know next class. I didn't see the last homework, so if you did it, please send it. And when you finish this one, you could also send it so you could get the credit for the homework. And remember, your homework overall is worth some points, which you shouldn't lose. Homework, where's homework on this thing? Homework is, I think it's 10%. Yeah. So, yeah, homework is 10%. So you don't want to lose out on a 10%. That could make a difference with your overall score. So just try and do it. The answers are there. If you're not sure how the answers are arrived at, then you could always make contact or mention it in the next class, and we could go through that. Okay. Any questions?
One question, Mr. Allen.
Huh?
Do I still have the opportunity to send you part B of the midterm?
The only problem I have now is that I don't want it to extend too long past. So if you could send it by before next Saturday, I'd appreciate that.
Okay.
Yeah, but and then if I really want it to be a clear copy, so it's easy to see and mark. Yeah. All
Okay.
right. I really want you all to, the ones that you didn't get right, go back over it so you could see, your mistake and learn. So the practice is very good for you. All right. So if you could do that, that would be good. Okay. Miss La Rochelle. Miss La Rochelle, you still there? Oh, you left it. Okay. Miss Fernanda. Miss Fernanda, are you there?
Still there, still
Any
there,
questions?
sorry.
Any questions? You straight?
No, no question.
Okay. Miss La Rochelle, I see you unmuted. You
No questions.
no question. Okay then. All right. Okay. Well, bye-bye. God's willing, we'll see you all next week, Saturday. And your next test, I guess that will have to be a sort of take home, but it'll be covering what we did today and I guess the last class, but it will be something that I'll allow you to do and send in. So you won't have to go to the IFS office for that one. So I'll just give that to you at the end of the class, next class. Okay, so all being well, we'll see you next week then. Bye-bye.
All right, bye.
Mhm.
Okay.
Okay then.